So another method also you can use, that is called as inspection method. So it is nothing but a matrix method. It is also known as matrix method. So now we can see about this method. So inspection method, we know that voltage which is equal to I into R, right? So you have to check how many loops in the circuit. Here we are having 2 loops. So your in inspection method, it has 2 cross 2 matrix. So you have to write in 2 cross 2 matrix R11, R12, R21, R22. This is your resistance. I, we don't know, we have to find out I1, I2. Then V in question itself they will mention V1, V2. So for using inspection method, you have to keep in your mind the off diagonal element should be positive, other diagonal element should be negative. So you have to mention R1 to R21 should be represented in negative. Now you have to fill this matrix R11. It means that the total resistance present in loop 1. Loop 1 alone. So you have to check only this loop. Here 20 ohms is there, 10 ohms there. So you have to add it. So 20 plus 10 is your loop 11 total resistance. 20 plus 10. Then you have to check R12. R12 means loop 1 and loop 2 common resistance. So here it mentioned as 10. So you have to put minus 10 because in formula itself we mentioned minus, so you have to put that minus. Then R21. 21 is nothing but the resistance which is present both the loop. So here it has 10, right? This is second loop, this is first loop. So 10 ohm resistance minus 10. Then R22. 22 means total resistance present in the loop 2. So 60 plus 10, it will become 70. So 60 ohms plus here 10 ohms. Then you just write as it is I1, I2. We are going to find out this current only. Then V1, V2. So V1 is nothing but loop 1 voltage. So here the source voltage is 20 voltage. So you have to check with the assigned direction with your actual direction. So this arrow hence at positive. So you have to write 20 voltage, positive 20 voltage plus 20 voltage. For V2, it is nothing but the source voltage present at loop 2. If they didn't mention any voltage source in loop 2 means you have to put 0 there. But here in loop 2 they mention 60 voltage. Once again you have to check with the direction. So the arrow ends at negative. So minus, here this is positive, this is negative. This arrow, the loop current I2 flows through positive to negative. So you have to mention minus 60. So 20 plus 10, 30, minus 10, here it becomes 70, I1, I2 equal to 20 minus 60. So using this matrix, you can form the equation and also you can use Cramer's rule also. So I am going to form the equation, then we will check with the Cramer's rule. So 20 I1 minus 10 I2 equal to 20. Then minus 10 I1 plus 70 I2 equal to minus 60. This is equation 1, this is equation 2. So, I am going to divide by 10 because the all numbers will divide by 10. So, it will become 3I1 minus 1I2 equal to 2. Then minus 1I1 plus 7I2 equal to minus 6. So, this is your equation 1, equation 2. The same equation you will be getting the previous method also. So, using your calci, once again you just check it. A1 is 3, B1 is minus 1, C1 is 2, then A1 is minus 1, B1 is B2 is 7, then C2 is minus 6. Your x value, it means that I1. Your I1 value is 0.4, I2 value is minus 0.8. So, they asked the current flowing through this 10 ohms resistor. So, I 10 ohms equal to I1 minus I2. So, I1 is 0.4, your I2 is minus 0.8. So, minus of minus 0.8, minus minus will become plus, 0.4 minus minus plus, so 1.08, it will become 1.2. So, I 10 ohms, the current flowing through 10 ohm resistor is 1.2 amps. So, you can go with any method. Suppose if you are applying KVL, if you are confused with positive and negative direction means you can use the inspection method and you can also cross check it whether you got the correct answer or not. The same problem you can use with Cramer's rule also. So, using Cramer's rule. Using Cramer's rule, you no need to form the equation. From matrix, you have to find out the determinant of the matrix and you can easily solve I1 and I2. So, for that you need del 1, del 2. So, del 1, del 2 is your unknown parameters I1 and I2. So, for finding del, so already you form the matrix, you have to take this matrix alone for del. So, it is 30, you can divide there also, divided by 10, it will become 3 minus 1 minus 1, here 7. So, this is your del matrix, you have to find out the determinant of the matrix. So, 7 into 3, 21, minus minus will become plus, plus into actual determinant, for finding determinant there also one minus will be there. So, plus into minus, minus, 1 into 1, 1. So, you will be getting del as 20. Similarly, you have to find out del 1. For del 1, you have to replace this column, 3 minus 1, you have to replace with 20 and 60. So, you already divided by 10 here, it will become 2 and minus 6. So, here you have to represent 2 minus 6 here as it is. You no need to change this column, you have to replace the first column alone. So, 2 minus 6 here minus 1, 7. Similarly, you have to find out the determinant. So, 7 into 2, it will become 14, 6 into 1, minus minus will become plus, plus into minus, it will become minus, minus 6 equal to 14 minus 6, 8. Okay. So, using Cramer's rule, your I1 is nothing but del del 1 divided by del. So, del 1 is 8, del is 20. So, if you are dividing 8 divided by 20, it will become 0.4. So, I1 is 0.4. If you are using KVL or inspection method or using Cramer's rule, the value are same. So, 0.4 is your I1. Similarly, you have to find out your del 2 value. For del 2, you have to replace this matrix 2 minus 6 with this column. You have to replace this column. So, here it is 3 minus 1, this column. Instead of 1070, you have to replace this 2060. It is divided by 10. So, here 2 minus 6. So, 3, 1 as it is, you have to replace only the second column. So, 6 into 3, 18 minus 18, because here minus is there, plus into minus, minus 18, then 2 into 1, it is 2. So, minus, already one minus is there, so minus into minus, it will become plus, so plus 2. So, your answer is minus 16. So, del 2, for that you need del 2 by del. So, I2 equal to del 2 by del. Del 2 is minus 16 divided by del. Del is 20. So, minus 16 divided by 20. So, equal to minus 0.8. So, I got I1 as 0.4, I2 as minus 0.8 using Cramer's rule. So, all the methods, the answer is same. So, I1 using Cramer's rule, I1 equal to 0.4, I2 equal to minus 0.8. They ask what current flowing through this 10 ohm resistor. So, I 10 ohms, which is equal to 0.4 minus minus will become plus, plus 0.8. The current flowing through 10 ohm resistor is nothing but 1.2 amps. Suppose in your question they are asking what is the current flowing through this 20 ohm resistor. So, 20 ohm resistor is the independent branch, independent resistor. So, 20 for I1, if you want to find out what current flowing through this 20 ohm resistor, current flowing through this 20 ohm means it's nothing but the loop current I1, which is equal to the current flowing through 20 ohm resistor. So, your current flowing through 20 ohm resistor is, which is equal to I1. What is your I1 value? It is 0.4 amps. Suppose if they are asking the branch current flowing through this 60 ohm resistor means this is also a independent resistor. So, I2 equal to 60 ohms, I60. So, I60 ohms equal to nothing but I2. So, the current flowing through this 60 ohm resistor equal to minus 0.8 amps. This is how we can find out the branch current or loop current using mesh. So, this is two loop method. We can see one more problem also using mesh analysis. So we are going to solve 3 loop using 3 loop. So determine the current through 5 ohm in the circuit shown in the figure. So this is 4 voltage source, this is 3 ohms, here 3 ohms, this is also 3 ohms, this is 5 ohms, this resistor is 1 ohm, this is 1 ohm, this source is 8 voltage and then this source is 6 voltage. So they asked determine the current flowing through this 5 ohm resistor. So first step 1, you have to identify how many loops in the circuit. So if I am considering this point to this point, so this is also one loop. I am going to consider this as loop 1. So I am going to mention I1. Similarly, this point, this point, this point. It will start from here, its ends at here. So I am going to consider this loop as I2. Then this loop as I3. So totally 3 loops in the circuit. Step 1, you have to identify how many loops in the circuit. Next step, you have to label the current I1, I2, I3. I1, I2, I3. I already labeled I1, I2, I3. Step 2, you have to assign the current direction. So I am going to assign clockwise direction only. So I am going to assign clockwise direction I1. This is I2. This is I3. So I labeled assign the direction, assign the current direction in clockwise and label the current. Label the current at each loop I1, I2, I3. I1, I2, I3. Okay. Next, you can go with KVL or you can use by inspection method also. I am going to apply inspection method. So using inspection method. So once you form the matrix, you can form the equation. That equation which is equal to your KVL equation using inspection method. So V equal to I into R. So here 3 loops are there. If they mention 2 loops means only 2 cross 2 matrix. Here it has 3 loops. So you have to mention R11, R12, R13. 3 cross 3 resistance. R11, R12, R13. R21, R22, R23. Similarly, R31, R32, R33. So this diagonal always positive. Other diagonal, non-diagonal elements you just mention as negative. Then I1, I2, I3 equal to V1, V2, V3. We just form the matrix using inspection method. We are going to fill the parameters. So R11, it means that the total resistance mentioned in the loop 1. Here 3 ohms, 3 ohms, 3 ohms. Total 9 ohms. So total R11 is nothing but 9 ohms. So in loop 1 alone you have to check 3, 3, 3. 3 plus 3 plus 3, 9 ohms. Then R12. 12 means the resistor which are both the loop current. So this is I1, this is I2. So if you are considering this I1 and I2, this 3 ohm resistor which are with both the loop I1 and I2. So you have to mention as per your formula, this is minus 3 ohms. Similarly, R13. This is loop 1, this is loop 3. Here it mentioned as 3 ohms. So here you have to write minus 3. Then R21. 21 means the resistance which are with second loop and first loop. So here it also minus 3. 22. 22 means the total resistance present in loop 2 alone. So 1 here 1 ohm is there, 3 ohm is there, 5 ohm is there. So 5 plus 3 8, 8 plus 1 9. So 9 ohms. Then R23. 23 means the resistance which are both the loops, loop 2 and loop 3. It is nothing but 5 ohms. So you have to mention minus 5. Then R31. 31 means the resistance which shared with third loop and first loop. So here 3 ohms, right? This is loop 1, this is loop 3. So 3 ohms. So you have to mention minus 3 ohms. Then R32. 32 means the resistance which shared with loop 3 and 2. It's nothing but 5 ohms. So you have to mention 5 ohms here. Then 3. The total resistance present in loop 3 alone. So 5 plus 3 plus 1, it become 9 ohms, right? So 9 ohms. So it will also become minus. So once again you have to check whether the diagonal elements are positive, the non-diagonal element should be negative. If you are using inspection method, you have to check other non-diagonal elements should be negative, the diagonal element should be positive. Okay, next. This I1, I2, I3, we don't know, we need to find out. And then this is V1, V2, V3, right? V1 means loop 1, the total voltage at loop 1. Here 4 voltage is there. Once you check with the voltage, you have to check with the assigned direction also. So here the direction which goes like this, right? So this is my assigned direction clockwise, minus plus. So it's the arrow head ends at plus. So you have to write positive 4 voltage, 4 volt, right? Then V2. V2 means the source voltage present at loop 2. Here you have to check with this assigned direction. The assigned direction go with minus to positive only here also. So if you are taking this direction here means it will go with the arrow ends at positive only. So you have to write plus 8 voltage. Okay. Next, the source voltage present at loop 3. So loop 3, the source voltage is 6 voltage. So the arrow shows that it goes with positive to negative. So it's nothing but minus 6 voltage. So each and every time the voltage source you have to check with the assigned direction. The arrow ends at positive means you have to take positive voltage. The arrow ends at negative direction. Assigned direction ends with negative means you have to consider negative voltage. So this is how we just form the matrix using inspection method. Now I am going to form the equation. So 9I1 row into column. So 9I1 minus 3I2 minus 3I3 equal to 4. This is equation 1. Similarly here minus 3I2 plus 9I2 minus 5I3 equal to 8. This is my second equation. Then minus 3, this is I1, minus 3I1 minus 5I2, then minus minus 3I1 minus 5I2 plus 9I3 equal to minus 6. Now you got the three equation, system of equation. Using your calci you can find out the what is I1, what is I2, what is I3. Okay. So using my calci I am going to check what is I1, I2 and I3. For that you have to go mode clear, you have to press mode clear. If you are pressing 3 times means it will show equation matrix VCT. You are going to solve by equation only. So you have to press 1 for equation. It will ask how many unknowns, 2 or 3. Here I1, I2, I3. 3 unknowns are there. So you have to press 3. It will ask what is A1, B1, C1, D1. D1 is nothing but equal to value. Here 4 is D1. Similarly, it will ask A2, B2, C2, D2. A3, B3, C3, D3. You have to press all the values, coefficients of these values. So A1 is 9. If you are pressing equal to means it will ask B1 value. So B1 is minus 3 equal to C1 is minus 3 equal D1 is 4. Then A2 minus 3 equal to B2 is 9, C2 is minus 5, D2 is 8. Then A3 minus 3 minus 5, C3 9 equal to D3 minus 6. So your I1 is 1.2, I2 is 1.6, I3 0.6. So 1.2, Y1 1.6, I3 0.6. So I found what is my loop currents, I1, I2, I3. But the question is, determine the current flowing through 5 ohms resistor in the circuit. The 5 ohm resistor present here, right? So you can find out I5 ohms. So you know what is your loop current I2, your loop current I3. So the current flowing through 5 ohm resistor is, you can write I2 minus I3, or you can write I3 minus I2 also. Only the sign will differ, the magnitudes are same. So I2 is 1.6, I3 is 0.6. So minus 0.6. So you'll be getting 1 amps. 1.6 minus 0.6. So I 5 ohms equal to 1 amps. So today's class we discussed, we solved 2 problems using mesh analysis. I hope all will understand this method. So you can go with Cramer's rules also, or you can go with the KVL. You can form the KVL equation also, the same equation you will be getting. Okay, thank you.